performing some vectorized operations in Numpy, and we're going to be demonstrating again how these vectorized operations are faster compared to, say, we were to perform similar operations with regular Python loops. So for our NumPy vectorized operation, we get speed and elegance. So we can do element-wise operations. We can boost performance and also boost the benefits. We can use some universal functions, popularly known as ufuncs. We can use broadcasting rules and vectorize aggregations. We're going to be getting into all of this. Broadcasting, we're not going to be talking about broadcasting in this video. I think subsequent video we're going to be talking about broadcasting. So vectorization is the type of operation that allows us to bypass explicit Python loops so that we can perform operations on an entire array data all at once. So this gives us a more efficient way of managing our data set. So let's get into it. Let's go into, so this was from our last tutorial. So I'm going to clear this so that we can have more space to work with. Okay. So the way we're going to do this, we're going to run through some vectorized operations. So I'm going to import NumPy. Okay, so we have NumPy importer already, so there's no need for that. So one more thing I need to do is, because I want to demonstrate to us again how the speed of execution when we do NumPy vectorized operation is faster compared to Python loops. So I'm going to import the time module from Python. So I'm going to do import time. Okay. Now let's define our data. So let's have data equals np dot arrange arrange. Okay, so you remember what we said. Arrange is similar to range function in Python. So we can set 1 million here, and then explicitly we can set our data type, d type. So let's say this to be np.float 64. So that's going to be our data type. Okay. Now let's see how this works in Python loops. To do that, we're going to implement our time. We're going to use our time module, and then we're going to call the time method on this time module. So to do that, we can do our start time, because the time dot time, like that. So this calculates our time start. Okay. Now let's have an empty list. Result loop. Oh no, loop. Let's set that to empty list, like that. Now let's perform our regular Python loop. Say for what is it? For I in data. So that's our data. This one. For I in data. Now we have to populate this loop. So we'll do result loop dot append. You remember? So how we populate list in Python. Dot append. Now we can perform our operation inside here. So let's have I exponentiation 2. Then show one the plus. So this is the operation we're going to be performing on this data. So we are looping through this data, and then we're performing this operation on the data, and then whatever the result of the operation is, we're going to populate it inside this result loop empty list. So we can have 2, and then 2 multiply by I let's do plus 1 as well. So it's just arithmetic operation anyway. So let's break out of here. Okay. Now let's look at, so this is our start time. Now let's define our loop time. Loop time. So for our loop time, we can do the time again. So this is going to capture our start time, and this is for our loop time. So time minus start time. So at this point in our execution, this is going to capture our loop time. Okay. So what is it called? Let's leave that, and then let's do for vectorized operation. And I think I can do this vectorized operation. Okay, good. And then for our vectorized operation, let's do like we did here, except in this case, we won't be using Python loop. So let's do for our start time as well, which is this. And then let's do for our vector result. So here we are result loop. Now let's do result vector. So for result vector, we can have this data. So we have data exponentiation 2 is the same operation we're going to be performing, plus then we can have 2 multiply by data plus 1, like that. Okay, so now we can have, instead of loop time, we can have a vectorized time, so which is going to be equals to time then minus start time, like that. Okay, so guys, the same operation, this is using regular Python loop, and this is using a vectorization in Numpy. Okay, now let's try to print some results to put this into perspective. Then we can do print, let's use f string, then we can do f, like that. So let's say loop time. For loop time, let's have this. So we had loop time A. So let's pass loop time, this one, for our regular Python loop time, and then we can format, so .4, so that's fixed point for floating point, that is 4 decimal places. So F, okay, and then let's pass second here. Okay, so I think that should do it for that. See, so loop time for our Python operation is 125.5182 seconds. Now let's print the loop time for our vectorized operation. The same operation, I want you to pay attention to these guys. So this is going to be vector time. For vector time, we're going to have this vect time. Now let's format to 4 floating point number like we did before, s a second. Now let's see. Here we had 125.5182 seconds, and here we had 47.7146 seconds. So which is significantly faster compared to this for our vectorized time. Now let's look at, just to put things into perspective, we can do print, then let's have f, that's f string, then let's do speed up time, okay, and then we can have loop time divided by vec time. Okay, vec time. For the vector, let's have okay. So no point 0f. Okay, so that's the formatting, and then x. Let's have faster like that. Okay, so this is going to give us how much time our vectorized time was faster compared to our Python loop. So if I press enter here, see, it says speed up time is 3 times faster, like that. So we're performing the operation on, what is it exactly? So 1 million data sets. So you realize it's quite faster compared to what we did before now. All right. What else? I hope I didn't blow this up in the course of typing. Vector time, time the time minus start. Okay. Right, let's do something else. We can do some element-wise operations. So we can define 2 arrays. For element-wise operations, which is the vectorized operation, remember we said for our vectorization, we can perform operations on an entire array elements without running through the overhead of Python loops. So for element-wise operations, we can do on one-dimensional array, two-dimensional array, three-dimensional array, as the case may be. So let's run through some of these operations. We can do for, let's do A equals np dot arrange, arrange, and let's have 6. And then let's do B equals np dot arrange 10. This good. And now we can perform operations on this. For instance, so this is A, right? And this is B. So if we do A plus B, no Python loops involved, just vectorized operation. Does this work? Let's see. Aha. Say operands could not be broadcast together with shapes. You know, we said we're not going to be talking about broadcasting here. Broadcasting is the mechanism that allows this kind of operation to work. So we've not talked about broadcasting yet. I don't want to jump the gun, so I'm going to skip this part. But I just want this thing to blow up so that you can see how important broadcasting is when we get to the point where we're going to be performing broadcasting. Okay, so then we can reset B. B could be np.array, and then we can pass Python loop here. So we had in A 1, 2, 3, 4, 5, 6 items. So let's have 10, 20, 30, 40, 50. We need one more, 60. Is that correct? Okay. Okay. Then we can do A plus B now. Now this works. See? Good. We can also do A multiplied by B. No loops involved. We're just doing this thing. It's just vectorized operation. It's just we're performing operation, element-wise operation across the array data set like that. We can also do exponentiation for one of our arrays. See, it works. We can even do square roots. So this is going to require, what is it called? A universal function. So we can do np dot square root. So square root is a ufunc in Numpy. So np dot square root of b. So square root of b, that is, did I get that right? Okay. Okay, so this is getting us the square root of each of the elements inside our B array. Okay. what we can do, we can also do a greater than 3. So this is going to get us all elements greater than, okay, so this is Boolean. So for we're returning a Boolean, so a greater than 3 is going to be true for all elements greater than 3. So false, false, false. So we have 4 and 5 for elements greater than 3. Okay. What else? So that's for, okay, let's do for, we can do for, what is it called? Multi-dimensional array as well. We can do for np.arrange. Let's do for 12.reshape. And then we can do 3 by 4. That's our size. Then when we do array, okay. So then we can vectorize this. We can do array multiply by 2. See? Everything is being multiplied by 2. We can even do array multiply by array. See? That is squaring everything. This is our original array. So it's squaring it 4, 9, 16, 25, like that. Okay. What else can we do? Let's do some aggregation and reduction. Okay. For aggregation and reduction, I'm going to stick with this array that we had. And then I'm going to use this to perform aggregation and reduction. So for instance, we can do np.sum. So we want to sum all the elements that we have inside our array. So I'm just going to pass array here. This should give us the sum of what we have here. Okay, so it says 66. So this is 5, 9, 14, 20, 27, on and like that. So that's 66. Anyway, what else can we do? We can sum across axes. Say for instance, look at this. If we do np.sum, we can do, we can pass array, and then let's set our axis to 0. So setting the axis to 0 is going to sum our columns for us. So let's see how that works. Okay, so it's summing our column for us. We're setting our axis to 0. If it were to be row, I think that axis is going to be 1. So this is summing each of our columns. So 0 plus 4 plus 8 is 12. 1 plus 5 plus 9 is 15. 2 plus 6 plus 10 is 18. On and on like that. And let's sum np.sum array, and then let's set our axis now to 1. I think this is going to sum across our rows. So good. So it's doing that. 1 plus 2 plus 3 is 6. 4 plus 5 plus 6 plus 7 is 22. And this like that. Okay. We can also get the mean of our array. Because np.mean. So we pass array here. This is going to get us the mean of the elements in our 2 by 2. In our 3 by 2. Yeah, 1, 2, 3. Oh, sorry. 1, 2, 3. 3 by 4. What am I saying? So the shape of a array is 3 by 4. The dimension is 2, which is 2-dimensional array. Pardon me for that mistake. So np.mean array is going to get us the mean of a array. So our mean is 5.5. We can also do for standard deviation. np.standard deviation. And then we can pass our array here. It's going to get us the standard deviation, which is 3.452, like that. Now we can also do the cumulative sum, and then for doing the cumulative sum, we can set the axis for which we want the cumulative sum. So if we do np.cum_sum, like that, and then we can pass our array, and then we can do axis equals to 1. So this is going to sum cumulatively across our rows. So what this is going to do is going to, okay, the first one is 0, So the next one is going to be 0 plus 1. So the next one is going to be 0 plus 1 plus 2. The next value is going to be 0 plus 1 plus 2 plus 3, like that. So if I press enter, this gives us the cumulative sum of our array. Just in case you're wondering, this is what we had before. This is the cumulative sum of what we did now. So the first one is 0. The next one is 0 plus 1, 1. The next one is 0 plus 1 plus 3. What am I doing? What is it? Okay, yeah, this is our cumulative sum. This is our original array. So 0, 0 plus 1, 1, 0 plus 1 plus 2, 3, 0 plus 1 plus 2 plus 3, 6. And then here we have 4. And then 4 plus 5 is 9. 4 plus 5 plus 6 is 15. On and on like that. You get the idea. So let's do the cumulative sum across axis 0, which is going to do for our column axis. Cum sum. So here we have array, and then we can set the axis to 0, like that. Okay, so this is doing across what is it called? Across our columns. So 0, 0 plus 4, 4, 0 plus 4 plus 8, 12. So 1, 1 plus 5, 6, 1 plus 5 plus 9, 15. On and on like that. So the next tutorial, I think we're going to be talking about broadcasting. So guys, please like, share, and subscribe. I'll see you guys the next video. Thanks for watching.